Hi, good evening. Today let us solve some problems on single phase AC circuits. Okay, these are all examination problems. So similar kind you can expect in your university examination. The first problem goes like this: an impedance coil in parallel with a 100 microfarad capacitor is connected across 200 volt 50 hertz supply. The coil takes a current of 4 amperes and power in the coil is 600 watts. Calculate the resistance of the coil, inductance of the coil, and the power factor of the entire circuit. Okay, so first let us collect the given data. Okay, given impedance of the coil is in parallel with 100 microfarad capacitor. So coil is in parallel with 100 microfarad capacitor, and it is connected across 200 volts 50 hertz AC, right? And it takes a current of, the coil takes a current of 4 amperes. So current flow through the coil, this is coil, say this is R and this is XL of the coil, and this is the capacitive reactance XC. So current flow through the coil is 4 amperes, and power absorbed by the coil, so P coil, let's call it as, is 600 watts. Alright, so you need to determine the resistance of the coil. So calculate R, L, and inductance of the coil, the power factor of the coil. Power factor of the coil. Alright, so these things we need to determine. So let's solve. So first let us find out the capacitive reactance Xc. Xc is equal to 1 by 2 pi Fc. Okay, so it is 1 by 2 pi into 50 hertz into 100 microfarad. 100. So that will give you Xc value of 31.8 ohms. Alright. And current flow through the coil is given 4 amperes. And we also know the voltage applied across the parallel combination. So 200 volts will come across the capacitive element as well as it will come across the coil as well. So by using this data you can find Z coil, that is impedance of the coil. So that is V divided by I. So voltage is 200 and current is 4 amperes. So that is 50 ohm. So Z coil is 50 ohm, which is nothing but Z coil is equal to R plus JXL. Alright. So okay, next what do we have? We have an important data related to power. So power consumed in a coil, P coil, can be given as I square into R. That's because the inductive element will not consume any power. So power is comes in only by the resistive element. So P coil is equal to 600 watt, which is equal to I square, which is 4 square into R. So that implies R is equal to 37.5 ohms. So you know Z coil, you know the resistance. So what you can find is the reactance. So we have Z square is equal to R square plus XL square. That implies XL is equal to under root Z square minus R square. So when you substitute the values of Z and R, you will be able to find the value of XL. Okay. So Z was 50 minus R was 37.5. Okay. So that gives XL is equal to 33 ohm. Having known XL, you can find L value. So XL is equal to 2 pi FL. So that implies L is equal to XL divided by 2 pi F, or L is equal to 33 divided by 2 into pi into 50. So you will get the coil as 0.1 Henry. Okay, 0.1 Henry. So the first part you have found. The resistance of the coil was found and the inductance of the coil was also found. Okay. The second part is the power factor of the coil. So to find the power factor of the coil, what you can do is you can draw the impedance triangle of the coil. So let me write impedance triangle of coil. So for impedance triangle, you can take R, the adjacent side, XL, the opposite side, and Z coil is the resultant. So XL value we have already calculated, right? 33 ohms. And R value was 37.5. And Z value we found it as 50 ohms. So you can easily find the value of phi. So phi is equal to cos inverse of R by Z. So you would get phi is equal to so when you substitute the values of R and Z, you will get phi value as 41.41 degree, and then power factor of the coil can be simply found as cos of phi. So that will give you cos phi is equal to 0.75. Okay, since it's a RL circuit, so power factor is lagging in nature. Okay. Just to add on, okay, instead of power factor of the coil, what if you were to find the power factor of the overall circuit? So in that case, slightly you will have to dig deep into the problem. Okay. So let me consider this case as well. Okay. Let me just extend this problem. Okay, you can write it something like, what is the power factor of entire circuit? In order to find the power factor of entire circuit, you will have to find Z equivalent. Okay, so Z equivalent is nothing but Z coil. Okay, this is your Z coil. And let us say Z2. So Z equivalent is Z coil into Z2 divided by Z coil plus Z2, or Z equivalent is equal to Z coil was 50 into, okay, the impedance, it's not 50, it is R plus JXL. So 37.5 plus J33 into Z2. So Z2, remember, it's a pure capacitive circuit, so it is 0 minus JXC, correct? So you would get 0 minus J times the XC value, 31.8, which we have already calculated. So you can just substitute minus J 31.8 divided by the addition 37.5 plus J 33 minus J 31.8. So you would get Z equivalent is equal to, in angle and magnitude form, you would get 42.3 at an angle minus 50.5. So therefore, the current can be found, I is equal to V by Z equivalent. V is 200 divided by 42.3 at an angle minus 50.5. So you calculate the current value, 200 divided by 42.3, that's 4.72 at an angle. This angle goes to the numerator, so basically net angle is equal to numerator angle minus denominator angle. So numerator angle is 0 degree, hence the net angle becomes 0 minus of minus 50.5, that is plus 50.5. Okay, so this is your phi. Okay, just to distinguish this phi from the power factor angle of Z coil, let us take this as phi 2. So therefore, overall power factor PF, say total, is equal to cos of phi total, and that is 0.636 leading. 636 leading. Yeah, so that's the solution.